software, in particular, which is one of the many pillars of open science. Just a word of introduction. I am a computer scientist. I have been spending more than 30 years doing research and education. I spent over a quarter of a century working in open source, and the last 15 years working for building and directing structure designed to serve the common good. And today, my focus is on software as a pillar of open science. You see the picture that you see on the left is extracted from the French Monitor for Open Science. This has been running for over 3 years now, and actually it shows the percentage of articles that actually use software in research. Maybe the text is a little small on the screen, but this is actually all the different disciplines. So you see that in computer science, in mathematics, in engineering, in astrophysics, in biology, in agricultural research, in social sciences, in geography, etc. In all the disciplines, software is used massively. And this is a very important point because it was folk knowledge until 3 years ago, and now thanks to this effort done by the French government to build this monitor, we have hard data that actually shows the software is present in all disciplines. So, what is that? Okay. So, and on top of that, we discovered also that 20% of the articles that actually mention the creation of software also mention the sharing of this software. So there is a lot of effort to do collaboration. And so it is the picture on the right shows that actually the three main pillars for open science today are, of course, open access, that was the center stage yesterday, but also open data. We need to have the data accessible, otherwise you cannot reproduce the results. And last but not least, we need to have access to the software, which is actually powering all the analysis and transformation that we do on this kind of data. And here the links are very important. When I see an article, a research article that says, we have taken this data for hygrometry in the north of India, for example, did this simulation and got this particular answer, it is important that I have exactly the right data at hand and exactly the software tool chain at hand to check whether the results agree and to build our own new result and research on top of them. And notice that software is a very special object in the space of research because it can be a tool. I mean, I can be using a piece of software built by somebody else for doing my research, but maybe the software that I am using is the result of the research of a colleague that has developed the tool, and maybe there is other people that use this software as a research domain. In particular in software engineering, people actually analyze how software is built. Now, if you want to go into this direction, the access to the source code is essential. Why? Because software doesn't come out of the sky magically. Software is created by humans to actually be executed on a machine. And as Professor Harold Abelson said, he's a very famous person at MIT. He actually contributed to the creation of the Free Software Foundation, of the Creative Commons. He created the Scratch system to teach young kids how to program graphically. In his book in 1985, he said the program must be written for people to read and only accessorily for machine to execute. What does it mean? Well, it means that you are actually software is never finished. You need to make it evolve. And so it is important that people can read the source code. So you see, for example, here a couple of small examples. On the left, you see a few lines of code that are extracted from the 60,000 lines of assembly code that were embarked on the lunar landing module in 1969 that allowed mankind to put a man on the moon, thanks to a woman, Margaret Hamilton, who actually directed the whole team that wrote this part of the program. On the left, you see the assembly code. On the right, you see the comments, which are in English, and these comments are not meant for the machine. These comments are meant for the humans. They need to understand and reuse it. If you move forward some 50 years, this is a fragment of the code which was part of COVID sim. It was the code for doing simulation of COVID evolution, written by an English biology, I think, and that was actually shared as open source. It allowed top programmers in the world to improve it, make it more efficient, more, you see even here the comments are super important, so the message sent to the human. So as Len Schustek, that was a board director of the Computer History Museum in Mountain View, wrote in a nice article in 2006, I mean, having access to the source code of programs opens for us a view into the mind of the designer. It is very important to keep it well. And where does open source come from? I mean, we leveraged the Software Heritage Archive that you will see in a few minutes to do a 70 years analysis of, actually 50 here, but it was over a 70-year span, 50-year analysis of the origin of contribution to open source software that you can see in our archive. And you see that even if at the beginning you had a rather general thing, so you have contribution coming from here, coming from Europe, from the US, then you have a dominance of US, then a dominance of the Europe, and today this is really spread around the world. I mean, a third of the software, new software that we see does not come from Europe, does not come from the United States. It comes from the rest of the world. So this is really, really a common undertaking from all of us. And software is not just data. Okay, you need to take care of software in a special way, because why is it special? There are so many reasons, but one of the reasons is that software actually evolves. If you have the list of the hygrometry values for the north of India on February 2025, this is fixed. Okay, this is the data from that moment. But if you have the source code of a project used for doing machine learning, this changes over time, all the time. And some projects may last decades. So the Linux kernel that is making my machine run today was started in 1991 and keeps evolving every day. So it's not just data, it's much more. And the development history is important. The other point is complexity. So some software are very big, so they are complex because there are many millions of lines of code. Some other software are very small, just a little script written in Python for doing some data management. But this little script uses tons of dependencies, tens, hundreds of dependencies. The little picture that you see on the right shows what happens if you run Python and you just write import matplotlib. This brings in dozens and dozens of different components that make this run. So the software can be complex just because you depend on many other components. And of course, there are many other reasons. And software is actually a precious knowledge that is risking to disappear. Many platforms are disappearing. So what is at stake for us in the research world? Imagine you have a piece of software that has been developed by a researcher and is used by a researcher. Then, of course, me as a researcher, I want to make sure that this software will be available to other colleagues for the long term. So I want to have an archive where to put it. Then, a second point, I want to make sure that I can find exactly the version that has been used for an experiment. If you change just a space or a tab in a Python program, it changes everything, okay? So it's really important to know which version you have been using. And so I need a reference for identifying exactly what I use. And then I need also to add metadata, which helps us discover the software that we want to use. And finally, since we are in academia, it's really important to be able to give credit to the author. So we need a mechanism for citation, for citing authors and giving credit to who develops this. Of course, there are many other things. I mean, before archiving, you need to build the software. So you need to share good practices for development, good practices for building a community around software. And even before, you need to set up policies in research organization. What should we do with the software that we produce? How is it shared? How is it archived? How do we give credit? How do we fund the different research software? So this is a matter for policy. You see? But today, let me focus now on what is needed for the first part: archiving, referencing, describing, and crediting. And for this, we need a universal archive. And luckily, now we have one. And this universal archive is called Software Heritage. Software Edge is an initiative that was started in 2016, so almost 10 years ago, to create an organization with a precise goal to go out, collect every single line of source code for publicly available software all over the world, making sure it does not disappear, so archiving it, and make it easy to use it and to analyze it, to study for different reasons. So in a nutshell, this is building a reference catalog. You know, most of the people today use GitHub, but when I started using a Forge, it was SourceForge 25 years ago. And then we have Bitbucket, and you have GitLab, and you have so many other structures. I do not know what you use in India, but I'm sure many people are using GitLab or Git or this kind of platform. And there are thousands around. Actually, we archive over 5,000 different platforms in software heritage. So you need a central place where you can find everything that you need. So this is a catalog. But it is also an archive. And last but not least, and very important, it is a research infrastructure. It is a very large telescope that helps us study the galaxy of software development worldwide over time. So how is it designed and built? Actually, this is one infrastructure which is centralized but open and shared. Okay, we only build this infrastructure to collect, preserve, and share, and we want to cater for the needs of cultural heritage, of research, of industry, and public administration. Today, this is the largest archive ever built, so we have already archived over 340 million projects from all over the world. Put it in a special structure that you will see soon, where we have over 22 billion unique source code files. And this again comes from many different platforms. So I cannot show the 5,000 ones, but you see GitLab, and other instances like this one. This is not a for-profit operation. It is a non-profit initiative done in partnership with UNESCO. We have a partnership with UNESCO since 2017, has been renewed in 2021. And of course, you can imagine building such an infrastructure has a high cost. So we need to have many partners and supporters, and you see here in the picture a few of the ones which are on board. And you see there is a lot of empty space. So I hope to see India coming on board soon, because we need you to. And how does this work? We actually built over time a gigantic crawler that actually connects to all the platforms that contain software source code. This is not easy because you need to build an adapter for each and every one of them. This allows to get at this list of 340 million projects. But then we go the extra step, we collect the source code, really archive, all the source code is in the archive, and we reread the version control history from the many technologies that are available, Git, Subversion, Mercurial, etc., and build a unique graph, which is technically a Merkle graph. It just means that we use cryptographic signature all over the place in the nodes. This graph today is 50 billion nodes, 800 billion edges. It contains all the history of software development over the past 70 years. Okay, and it actually is not that big. It's only 2 petabytes of data, which is a little bit too much for my machine, but it is not a lot for people use for doing research in particle physics, for example. And each of these nodes is actually identified by a precise cryptographic signature that is composed of the hash of the content and the prefix that tells you what it is. And this can be a file content, a directory, a revision, a release, a snapshot, an origin. But we can add also other qualifiers that allows you to tell you where this file has been found inside the archive. The important point to say is that this is now an ISO IEC international standard. It is 18,670. This is an ISO standard. Just this morning I got the message from ISO that the final version is ready for proof reviewing, so in a couple of months this should be out. And so it is a standard which is already adopted in industry and different other organizations to reference source code. And since, let's say, since an example is worth 1,000 words, I would like to show you very briefly some example of what you can do. Okay, so let's say on these slides that you see here, everything which is in blue is a link. I will be sharing the slide. So you click on the link and you see some example. But for the sake of brevity, let me do it this way. So let me see. Okay, so you see here, I'm entering into the archive, looking up a particular piece of source code. You are visiting the archives here. So it is not just an archive, right? You really have the source code inside. You can see the code, how it is. We can select a fragment of this code, for example, and you see this red tab there, which is present all the time. This red tab pulls out the reference to the particular source code that I can copy, put in an article. It is already finished. Let's see. Put in an article, put in a comment, put it in a contract, and when you click on the link, you get exactly in front of the same fragment of source code in the same context, the same version, same revision. And this is forever, because this is an archive. It is not a code hosting platform that can disappear. Okay, so this is the first thing you can do. The second thing is, okay, now that I have it, why is it interesting for doing research? Because now, being in India, I can say you can spice up a publication, and when you spice up a publication, it means you imagine you have an article where you are describing a particular algorithm. This is an article of mine since 2012. You have the code, but the code is not exactly what you have used. But here you can put the same link, and when you have the link in, you can end up in the archive in front of exactly the real code, not the one you had to shorten to fit the page limit. Okay? And so a researcher can find exactly what they want and share it. The other thing is, okay, now I have the possibility of sharing my code, but can I actually get the citation or tell people how to cite this code to get credit for what I have done? Well, this has been actually released a few weeks ago. Yes, you can go on an archive, and you see there is the orange tab. This orange tab allows you to pull out a full citation. This is for now done in BibTeX, which is a lot of people in mathematics and physics, but we will also add other formats for the citation. And this works by just adding a specific metadata in the archive, which is standard. And okay, now all this is fantastic, but imagine that my code is not up to date or not yet archived in the system. What can I do? Well, today you can very easily go to the software archive, look for a browser extension. This is the browser extension that works for Firefox, for Chrome, you install it. This is, you have installed this extension, and this will bring up this little color tab. When it is green, it means that the thing is already archived. If it is another color, you click in the archive. You get immediately to the archived place, and there you can extract your reference. So you see, so super easy to do for a researcher today. And you can go and archive everything that is relevant to you, not just your software, but also software that you use. Okay, so let me see. I have 2 minutes left. Let's see. I add a video because I prefer to do it in real life, but it would have taken maybe a couple of minutes more. So just for the sake of going there. Now you can tell me, but who is using this? Is this used by somebody? Yes, there are quite a lot of adoption indicators. For example, the computer graphics community has a special place where they actually check the quality of the software associated to article. This is called replicabilitystamp.org. Now they add to each of these stamps the pointer to the exact version that has been qualified in the archive. If you look at an analysis of research article done by people and presented in the Open Science European Conference 2 years ago, you see that software hash identifier are actually used very often. There are recommendations in France, for example, ANR recommends that software developed by public funding is archived this way. And if you look at adoption indicator for infrastructures, we have actually been running a few European projects in the framework of the EOSC, the European Open Science Cloud, to interconnect software with many other platforms. So now there is a connection with EpiScience that you have seen yesterday in the presentation by Raphaël Tournois, but also many other kind of connections. And I do hope we will have connections with the Indian infrastructure. So this is a revolutionary infrastructure. Let me, last minute of the presentation. It is a Library of Alexandria in one sense, but your Library of Alexandria go on fire. So here we actually make copies through mirrors all over the place. Why not in India? So if one goes on fire, the others stay. It is a software graph, not just an archive. Not any software graph, but it's a Merkle graph. So it is a sort of blockchain. And it is a pillar for open science, but also it is an incredible playground for big code, because we actually remove all the details and we keep in this graph only the key part of this information. So you have application in AI, I know it doesn't show there, in AI, in public administration, in software engineering, in cybersecurity. So just finishing, these are some highlights from this year, 2024-2025. So we started a project to actually do massive connection with publication and software. We were in touch with the people in AI and machine learning, in particular Hugging Face and ServiceNow, that released the model, large language model for coding called StarCoder 2, trained on software heritage. There is a project funded by the French government to use software heritage for cybersecurity analysis. We have shown the first result in academic interoperability. And the French government has also funded a project called Code Commons that actually will expand the software heritage to make it the reference platform for creating data set for large language model, machine learning, and AI related to coding. And in January, just last month, we had the annual meeting at UNESCO with 250 people present. And also, we were very happy to welcome Mr. Abhishek Singh here from India, who was present in one of the panels, in particular on AI. So let me conclude. I believe, and I hope you will be agreeing with us, that software presents a unique opportunity. It is a vendor-neutral open source infrastructure, worldwide long-term non-profit, and it is already able to enable archival and reference for the needs of open science with the cost mutualization. So instead of rebuilding everybody its own archive, we can share the same one. And here is my call for action for you. I hope you like what you see. Please show it around you, show it to students, to researchers, to engineers. My personal experiences, as soon as they see it, they love it and they adopt it. But it is not yet known enough in every country. You should try to include the software heritage in your open science policy the same way as France has done in 2021 in the National Open Science Project. Let's try to work together to integrate software heritage with your institutional repository and platform. This is not difficult to do technically, it's just a matter of working together. You should also join, I invite you, India, to join the software heritage initiative. It is a way to have a seat in the place where we take decision on where the software heritage institution will go and support the sustainability. You can also get involved. Everything we do is open source. You can build new application on top of this. And I'm finishing by leaving you this QR code here. This points to the annual report that we published just a month ago, so you have a global view of all this. Sorry for taking a few minutes over time. Thank you very much for your attention.
Long live India and France friendship.
And I will go now back and give him back the